right along. This is FRQ number 2. So part A asks for the the V. So FC equals FG. FC is mv squared over r, and FG is gmm over d squared, and the d is equal to 2r squared. I mean, not 2r squared, just 2r. The m cancel out, so v squared equals to gmr over 2r squared, and v is equal to rad gm over gmr over 4r squared, and the r's cancel out, so it will be equal to this, gm over r for part A. Part B asks for time, so we derive v equals rad gm over 4r. And v is the same thing as circumference over time. So we cross multiply. C is equal to 2 pi r times 4r, and you divide gm, and this is all under rad, and this is equal to t. So r, when we multiply this into there, it'll be 2 pi 4r cubed over gm, and then you can bring out the 4, so it'll be t is equal to 4 pi r cubed over gm for part B. Part C asks for energy, so E total is equal to K of both planets, so K plus U, the potential energy, and U is always negative, so ET equals E total is equal to 2K minus U, so ET is equal to 2 1/2 m v squared minus gmm over d, and d is to r. This cancels out, so ET is equal to m v squared is gm over 4r minus gmm over 2r. They all have the same variables of gm squared over 4r over r minus, so you can subtract it, and this is equal to gm squared over 4r, and it is negative for part C. Part D is asking for the angular momentum. So L cis is equal to mvr plus mvr for the two planets. And this is equal to mvr, so L cis system is equal to 2 mvr we can substitute the v for rad gm over 4r. This 2 and the 4 cancels out, and then you can multiply this in, so it's be m squared and r squared inside the radical, so g m cubed r, and the direction of this would be clockwise. part E is asking for the new orbits. So the radius from the center mass and to the planet 3M is equal to md over 4md when for adding over 4m for m total on the bottom, and is equal to 0.25 d. So the center and mass would be 0.25 d from 3m, so it'll be around here. This is going to be the orbit of 3m. And it will be about here. And then this is going to be the orbit of m. And the orbit of m will be about here, something like around here. Okay. So part F is asking for angular speed of the 3m star. So the distance from Rm would be d minus R3m, which is equal to d minus 0.25 d, which is equal to 0.75 d. So R is equal to 0.5 d, the original R. R3m is equal to 0.25 d, and Rm is equal to 0.75 d. So this means that R3m is equal to R3m is equal to 1/2 R, and Rm is equal to 3/2 R. So to find omega, we set Fc equals Fg. So M3m R3m omega squared is equal to Gm3m over d squared. So 3m and 3m cancel out. So omega 3m squared is equal to Gm over d squared. This d is 0.5 r. No, this d is 2r, so this would be 4r squared. And then times R3m. R3m is 1/2 r, so we can substitute that in. So omega 3m is equal to rad Gm over 4 times 1/2 is 2, and r squared times r is cubed. So omega 3m is equal to Gm over rad Gm over 2r cubed. Part G is asking if, okay. So the physics student statement that the orbital period of the more massive star is greater than the orbital period of the less massive star is incorrect, because omega 3m is equal to omega m because it's in a binary system. You can also show this in t equals 2 pi r over v, and r over v is the same thing as omega on the bottom. And since omega 3m and omega m are the same, the t would be equal for both of the stars. So part H is asking for the new orbital period. So tn for new is equal to 2 pi over omega 3m, as we found over here. So Tn is equal to 2 pi over rad gm over 2r cubed. And you multiply this, you multiply by the reciprocal, so it will be 2 pi times 2r cubed over rad gm. And then this is the OT. And this would mean that the new orbital period has decreased because this is OT. The OT has the OT is bigger by a multiplier of rad 2. So orbital period would decrease because the T new is less than the T old by a factor of rad 2. I asked to compare V3m and Vm. So V3m over R3m is equal to omega 3m. So this means that omega 3m times R3m, and R3m is 1/2 R, is equal to V3m. So this would mean that V3m is equal to radical GM. This 1/2 squared is 1/4, so 8. And R squared over R cubed is R, and is a V3m. And then omega 3m equals omega m. So this means that you can do the same thing for Vm, for the other math, the smaller m star. So this is equal to omega 3m, which means that Vm is equal to this times Rm, and Rm is 3/2 R, as shown before. So this means that Vm is equal to 3 squared is 9, Gm, and 2 squared is 4, so we 8 R. And then V3m over Vm is equal to this over this. And this is and the rad Gm and R's they cancel out. So this will be rad 1 over 8 over rad 9 over 8, and you multiply the reciprocal. The 8's cancel out, so this will be equal to rad 1 over 9, and it's equal to 1/3. So the ratio for V3m over Vm is 1/3. Part J asks for angular momentum. So L3m is equal to 3m V3m R3m. So L3m is equal to 3m times V3m solved over here. And R3m is 1/2 R. So L3m is equal to 3 halves. I multiply the m side, so it'll be gm cubed, and r will be on top because of the expression, and this will be over 8. And lm is equal to mv m rm. So lm is equal to m times this and times 3 half r. So lm is equal to 3 halves times 9 over 8 gm over 9 over gm cubed r over 8. So L3m over Lm is equal to this over this goes to 9. The 3 halves cancel out. All the top cancel out besides the 9 over 8 and 1 over 8. So this is the same thing as rad 1 over 8 over rad 9 over 8. And then this is equal to 1 over 8 times 8 over 9. And this is equal to 1/3. So L3m over Lm is 1/3. Part J is asking for angular momentum for Lm 3m over L system. So part K, so L system is equal to L3m plus Lm. So this is the same thing as 3 over 2 gm r cubed. And you can factor out the 9 on top, so it'll be 3 times 3 is 9 over 2 rad. This thing as this. And 3 halves plus 9 halves is 12 over 2, and 12 over 2 is 6, so this is the same thing as 6 rad. So the L system is equal to 6 of this. So L3m over L system is equal to that over 6. All of this cancels out. So 3 halves times 1 over 6 is equal to 3 over 12, and it's equal to 1/4. And then part L is asking for a ratio of kinetic energy. So K3m is equal to 1/2 3m d3m squared. So this is 3 over 2m times p3m squared. So v3m is this, and you square it, so it'll be gm over 8r. And then this would mean that K3m is equal to 3 over 16 gm squared over r. And then you apply this to Km, so be 1/2 m Vm squared. So Km is equal to 1/2 m Vm is Vm squared is 9 over 8 gm over 8r. 9, yeah. So Km is equal to 9 over 16 gm squared over r. So Km over K3m is equal to this, and gm squared, all that cancels out. So 9 over 16, what's our reciprocal? Is 9 over 3, and 9 over 3 is 3. This is part I. This is the whole FRQ. Thank you.